Hello everyone, in this video I'll be explaining you the problem distinct elements, and it was asked in Codeforces Round 1058 for division 2. So let's read out the problem. Given an array C, let f of C be the number of distinct elements in C. For example, f of 1 to 2 is basically 2 because we have 1 and 2 as unique elements. 2 is repeated 2 times but it will be counted only once. So that is the thing they've said, because there are two distinct elements in 1 to 2, which is 1 and 2. And also define C of I to J. Basically, if C is an array, so it is having element, it is like a subarray, like element from I to J is as an subarray of C bounded by positions I and J. That is the array Ci to Cj. There is an array A of size n, and an array B of n elements is constructed such that B of I is basically f of 1 to I plus f of 2 to I till f of I to I, f of A of I to I. So don't worry, this is mathematical terms I'll be telling you. So you are given the you are given the array B. Find any possible A with elements, A of I is basically greater than equals to 1, less than equals to n. It is guaranteed that at least one possible A exists. So this is very important, like we have answer for this, so we'll have to return one of the A. And the definition of subarray they have given here basically, so I'll be telling you. So here we have test cases. In the input we have first test cases, then we have integer n denoting number of elements, size of A and B, and the second line contains elements bi's, and the elements will be from 10 power elements are from 1 to 10 power 18, and it is guaranteed that the sum of n over all test cases does not exceed 10 power 5. So let's take this example and understand. We have so let me explain you what they're saying. In the first example, n is 3, basically size of the both A and B array, and we have 1 3 6. So before dealing with example, let's understand what they're saying. So they will give n as length of array A, or you can count length of array B also. So basically they'll give B, they'll give B. You will have to construct A A based on B. So what is the definition of B? So Bi, if you want to find, so that is going to be f of A from 1 to I plus f of A from 2 to I plus up to so on it will go f of A from I to I. So this is the definition of Bi. So basically Bi they have given, okay, and we'll have to construct A. So it is a reverse order, we'll do it, don't worry. It is just observation problem. If we observe carefully, it will happen. And what is f of A of let's say I to J? So this is basically number of unique elements, in A from index I to J. I think it is visible, yeah. So I think you have understood. Let's say you have A 1 2 3 4, right? Your I is here, J is here, let's say. So this is f of this is A basically. So your f of A from I to J is going to be f of, what is this, 2 3 and 4, and in this how many unique elements are there? 3. So 3 is the answer. Let's say you have taken I from here to J, right? So again your f of I to J will be 2 3, only 2 3. So this is 2 3, and here unique elements we have only 2 elements we have. So yeah, 2 number of unique elements. So this is definition of A of I to J. So now this is interesting problem. This is too good. So they have given bi's. Okay, so and now they're asking us to find element ai's. What is the element such that this is the answer. Now if you try to think of a way, let's say my array element a, if I take only array element, if let's say n was 1, so in that case my array element, let's say if I put a as 1, you have 1. Now your b element is going to be what? So according to definition, b of 1 will be your, I mean here I and j I'll be taking 1 based indexing, I comma j, it is 1 based indexing. Okay, greater than equals to 1, less than equals to n. So your b1, if you want to find, so what you can do is it will be f of a from 1 to 1. Why here 1? Because it is it is the form bi. So bi here I is 1, so from 1 will start till 1 only will go. If let's say if you had b2, so you would have this way, f of a from 1 to 2 plus f of a from 2 to 2. So basically your this right hand side, whatever you have j, so that will be same only, I mean it is same only, but your I will start from 1 1 2 3, this thing. So now we are trying to find b1. So when you're trying to find b1, your it is going to be f of a 1 to 1 is from left, this is I and j in the form of I and j, right? So from 1 to 1 we have only one element, so it is f of 1, and only one unique element is there, so it is 1. So your b1 will be, I mean b1 will be 1. This is basically I'm trying to explain the problem statement. So this is nothing much. So let's say array elements you have 1 and 2, a element has 1 and 2, so what will be your b elements? So your b element, let's try to find. So b1 you will have to find and b2 you will have to find. What will be b1? b1 is going to be f of a, it will start from 1 till whatever index you have, till 1 to 1. So these both are same, so you will stop it here. So f of 1 to 1 is like from index 1 to 1 is only one element you have, so a of 1. So this is going to be a of, I mean what is the element, I mean how many unique elements are there? So it is going to be, it is not a of 1, it is just 1, because I'm taking a from 1 to 1, so one element only we have, and in this you have one unique element, so 1. So your b1 will be 1. What about b2? So b2 is going to be f of a from 1 to 2, right? Since it is 2, it is starting from 1 till 2, plus f of a starting from 2, you are starting from 1, then it is 2, from 2 to 2. So now the thing is, since you had only one element initially, now from 1 to 2 you are taking. When you're finding b1, you had only one element. When you're finding b2, you'll start from again leftmost side till this thing. So so here your elements is going to be 1 comma 2 plus 2 to 2, it is going to be from here, right? It is 2. So how many unique elements are there in this? 2. How many unique elements are there? 1. It is going to be 3. So your b2 is going to be 3. So now again, if you try to find, let's say you had n is equal to 3, so your b3, if you try to find, what it will happen is, so whatever like b1, if you see like only one element were there, and if you're taking b2, so whatever one element was there initially, you're adding one more element to that, right? So one more unique, I mean different, whatever element present initially, apart from that different element you're adding. So in this case I'll be taking serially, like 1 I'm taking, and the next element is 2, that's why I'm adding it here. And then if you want to find 2, since you had only one in b1, the next in b2 when you're going, so you are adding 2 to it. So here you will be adding 2, but 2 will also be added separately, according to the definition. So if you try to find, let's say now b3, your b3 will be since b2 had 1 2, so whatever you had 1 2, and one more element, a new element will be adding, right? This will be your f of b3 plus f of, now here one more element you are adding extra, right? So it is going to be 2 comma 3, and one more extra element you are adding, right, according to the definition, so it is going to be 3. So in this, if you try to find the unique elements, are here 3, here 2, here 1, so your f of b3 is going to be 6, right? So if you take 3 as the third element, so your b is going to be 136, and which is there, like you have b as 136, for that corresponding you are finding 1 2 3 as the element. So I think you have understood a bit, not in detail, so don't worry, I'll be telling you. So basically my main idea was, during the contest was that, so whatever b element they have given, so here whatever value you have, so b first value will always be 1 only, because when you're finding only one element, so you'll have, according to the definition, you'll have only one element, one unique element. Then now when you're adding the next element b2, I mean, if the length of the array is 2, when n is 2, so in that case what you're doing, you had, one only one element, right? Here you had c, only one element. In that element you will be adding, extra element, and one more extra element you're adding according to the definition of bi. I mean, this is the definition, so you'll be adding one more. So when you're adding one more, so now what happened is, so it had only one, so the next different element when we add, so this will make, one more as a unique element. Here you had only one unique element, but other element when you are adding, so this will have whatever unique element previously it had plus one as one of the unique element. And in this also, if you see, this part was not there in b1, it was not there, but according to definition you are adding that part. So when you're adding that part, so like it was 0 initially unique elements, now since 1 you have added, so it will contribute 1 to the answer. So what I'm trying to say is that when you find b1 you had 1 as the answer, when you are finding b2, and when you're finding b2, so what will happen is, you will try to, according to the definition, you will try to add one more extra elements to all the, this f of from 1 to i's, you will be adding one more extra, so that will contribute 2 to the answer, right? So initially you had only one element, now when you're adding for b2, when you're calculating, so you will be adding one unique element, and then one more unique element you're adding. So basically what it is happening is, you had only one unique element, but one more according to b2 you got 2 f of this f of ai's. So when you got 2 f of ai, so you will be having 2 unique elements, right? So initially 1 you had, but when you're adding 2, so 1 plus 2 is giving you 3 as the answer. So now you have, let's say, 2, this f of, when you're calculating b3, so what you will be doing is, you will be putting, 3 as unique element in this. If you put one unique element in this, so its uniqueness will be increased by 1. So initially it has 2, so its uniqueness will be increased by 1, which is going to be 3. Again, now here it is going to be 3, so its uniqueness is going to be previous plus 1, which is 2, and one more f of you don't have, right? Which is considered as 0, but you will be having one more, 0 plus 1 is giving you 1. So b3 is having 6 as the unique elements. So for this example you have understood. So let's try to take one more example. Second example you will understand. N is 3. Now second example is 1 3 5, right? When you have 1 3 5, so when you're finding b1, A elements will be finding, you 3 elements will be there, B1 when you're finding. So let's say you start A1 with 1 only. I mean, always you start A, first element is 1. So whenever you have 1, so its value is 1 only, right? Only one unique element you have according to the definition. So if you write this way, f of A of 1 to 1, so this is going to be f of 1 to 1 is 1 only. Like what I'm trying to do here, basically I'll start A with 1 and try to fill the next element. Okay, when I'm filling the next element, so I'll be doing it how I want to fill it. So that is the we'll have to do it. So f of only one unique element is there, so its answer is 1, so which is given as 1. Now when you're finding 2, now my next if you go according to this definition, your f of B2 will be f of 1 to 2 plus f of 2 to 2. So this is the thing, right? Which means one more element you're trying to add. When you're trying to add one more element, so yeah, what we'll do is previously whatever you had, like 1 you had f of 1, let's say you want to add 2. I've added 2, right? According to definition it is going, so 2 we have added. So here the uniqueness is 3, and here the here uniqueness is 2, here 1, and we're getting 3 as answer. And B2 is 3 we have getting. When you put A2 as 2, so you're getting B2 as 3, so which is given in the question. This is given in the question, which is true, so this is also fine. Now the third element we want to fill it. So when you're trying to fill the third element, so now your B3 is going to be f of A from 1 to 3, like 2 elements were already present previously, one more extra you're adding, right? It means like previously you had 1 comma 2, f of 1 comma 2, but since you're finding for B3, so this is going to be increased by 1, right? If it is going to increase by 1, which means whatever previously element you had 1 and 2, that will always be there. That is like whatever element you had, that will be always there according to definition. And the third element what you are putting, that matters what you are putting. And here also, like f of it will be from 2 to 3. So f of 2 to 3 means it is starting from 2, one more element is there, that we'll have to find it. Now the last element is going to be f of A from 3 to 3. So the last element we'll have to find, and this is A of what element you'll be finding. So this is the thing. So when you insert a different value in this, so like whatever previously you had unique elements, that will add +1 to the answer. Like B2 you had 3, and you have if you add 3 unique elements, the 3 if you want to add here, so it will contribute as 3 unique elements, this will contribute 2 unique elements, and this will contribute 1 unique element. So in total you have 6, but in the question they have given you have only 5. So if they have given you as 5, so this 3 is not a valid one. So what you are trying to do, you will not be inserting this 3. So you want like 3 you had earlier, and you want 5 as in the next one. So only the 2 elements, among these 3, so only you'll have to place the element in such a way that only 2 is added to the answer, not 3. So if 2 is added to the answer, what I'll be doing is I'll be trying to insert this 1. If I try to insert this 1 here, here also 1, here also 1, here the uniqueness is here the uniqueness is still 2, and here the uniqueness is 2, and here the uniqueness is 1, and this will contribute 5 to my answer. I think you are understanding, right? So if it were in the next example we have here as 4, if that was the case, So what would you have inserted here? So initially, I mean, the third example what they've given, so that let me write it. 1, 3 and 4 we have in the third example. So so b2 you have got as 3, but you have in when you're finding b3 you have 3 sets wherein it will contribute to the answer. So you want only one to be contributed. If you want one to be contributed, what you will be adding? You will be adding 2 will be adding. If you add 2, so this is contributing to my answer, and this uniqueness is 1 only, and here the uniqueness is 2 only, and which is giving me 4 as b3. So from this what we are understanding is, so whatever element previously, I mean, always your a will start with 1 and b will start with 1 only. When you have b as 3, so which means you had like f of, I mean, b1 you had 1 only, and when you're finding b2 you have 2 sets this type, right? You have 2 sets. So if you add other element, unique elements, so it is going to contribute initially 1 you had, and these 2 additional it is going to contribute. So 3 is the answer. So you'll have to check if that is the correct or not. Since here 3 is there, so that's why you add 2 in your a. So that is correct. But when you're finding the third element, now in the third element what we're doing, so when you're finding the third element, you have 3 f of this thing, and since b2 is contributing, b2 is 3, so if you add the different element among these sets, so your answer is going to be b3 is going to be 6, because 3 is b2 is 3 only, and these 3 unique sets will contribute to plus 3, so it is going to be 6. But in the question it is 5 only. So if it is 5, you try to contribute only the unique in 2 elements, I mean 2 f of this according to definition. In only 2 you will have to do it. Whenever it is 4, you try to put it only 1, right? So by observation what I found is that, so whenever the difference is whatever difference you have, its difference is here the difference is 2. In the first example we had 136, b as 136, right? So this b3 whatever you have 6 only is there, but here also it is 6 only there, and when you try to calculate the way I was doing, it is also 6 only. But now when we calculate, your b3 is going to be 6, but in this example you have b3 as 5, right? So the difference is what? 1. So whenever one difference is there and you had 3 sets, in this set whatever in this value is there, you try to put those values in these 2 in such a way that if you put whatever value is there in this particular set, so this will not affect to the answer, but these 2 will affect to the answer, right? It is going to affect these 2. So if this is affecting, your 2 is getting added to my answer, and initially b2 was 3, so 3 plus 2 is giving you 5. So in the same way you will be finding what should be my if I put a unique element, what will be my b3. So that is 6 only, but in your third example it is 4, so the difference is 2. So among these 3 sets what you will be doing is, you want to make sure in such a way that only the difference is 2. So if difference is 2, which means only one unique I mean in only one set the unique has to be there, or else I mean this will affect to the answer. So whatever element is present at this position, which is like 2, so that if you put it in all the sets, if you put it 2 here, if you put it in all the sets, so that is going to increase the answer by only 1, because the 2 is already here also and here also, and 2 is not there at this position, so this will contribute only 1 to the answer. And initially previously b2 was 3 and we are adding only 1, so that is going to be 4. So I think you guys understood the concept. right? Now the question comes, how do you solve this? So for solving, what I'll be doing is I'll be taking certain variables. So first is like I'll be taking f. This will find the actual value. What is the actual value? I mean, actual value means at in the B array, what should be the actual value? So initially, as we know, it should be 1 only, right? So for the first time it should be 1, and for the second time it should be 3, for the third time it should be 6, because when you go to the definition, when adding a new element, so it is going to be this. When you add the fourth element, I mean, if you try to find b4, if you try to insert a unique element, let's say a is kind of this thing, 1 2 3 you had, now you added 4 element, so in that case your f is going to be 10. Why 10? Because b3 is 6, and you have 3 f-offs according to this definition, and when you're calculating f4, so you have 4 f's, and you'll be inserting the unique element 4, so it is counting 4 to the answer, so 6 plus 4 is going to be 10. Now if you want to find b5, so it is going to be 15. It will be added 5 to 5 here, and if you calculated 1 2 3 4 5 6, so it is going to be 21, because 15 plus 6 is going to be 21. So I think you guys understood. So I'll be taking f as the actual value, what we have. It will start from 1 only. Now I'll see what is the b value present, because b is given, we'll have to find a. So I'll take a as one of the vector. Initially it will be empty, and what I'll do is I'll be running a loop, for loop I from 0 to n minus 1. Initially f value I'll be keeping it as 0. Why 0? I'll be telling you, because initially we don't have any element. Now your f is going to be increased by the size of the array. Here it is 0, right? I'll put a dot size only. It is 0 only, plus 1, because the previous how many elements are there in the array, so in that we'll be adding one element as unique element, and the last one is going to be one of the unique element. So that's why whatever f value we have previously, in that we are adding the total array size, I mean total f's, and then at the end one more we have extra f, because we are calculating the extra one. So this is going to be our f. Now we'll have to find if this f value, whatever we have got, if it is equals to b of I, means whatever value we have calculated and the value present here, if both are same, so I'll take one variable number that will be initialized to 0 initially. When if it is same, so I'll increase the number by 1, and I'll push this number into my answer vector a, right? I'll do this way. Else what I'll do is, if it is lesser, so I'll find the difference. I'll be putting it in D, and the difference I'll be finding in since the actual calculated value is f, it is greater, so f minus b of I, I'll be doing it. When I do f minus b of I, I'll get some difference. So as I said, if the difference is in the first example we had b as 1 3 and 6, so in that case your difference will be 0 only, because the whatever f you are calculating here, it is 6, and b of 3 is also 6, so in that case you will be adding the next number. But here it is 5, right? Which means the difference, your d value is going to be 1. So if d value is 1, so what I said is like, when you're calculating b3, so your f of like 3 times will come, right? If it is coming 3 times and your element is 5 and your b2 was 3, so only in these two element, I mean these two f's, the uniqueness has to be there. So whatever element is present here, that element only you just repeat it. So which means it's like whenever d is 1, so what we are doing is, you will be pushing into the element a of d minus 1. This will be putting, like whatever element is present at this index, that only you will be putting here, in such a way that the element present here, it is not counted, but here it is counted. In this case, let's say your difference is 2. When your difference is 2 and your b2 is 3, so only one uniqueness has to be there. Only one uniqueness, if that is going to be added, so whatever element is there at this position, you just add here. So this will not count into uniqueness, this is also not counting uniqueness, but here it will be counting into uniqueness. So that's why d is 2. So the element whatever here you will be having, right, d minus 1 if you do, because it is 0 based indexing. That's why if you do it, it will count to the answer. And at the end, what you will have to do is, you will have to initialize your f with the previous element. So it is going to be b of I, right? So now whatever element you have, you just display it. I think you guys understood. Conceptually you have understood. Now let's try to code it up. Pseudocode also I think you have understood. So we have test cases and we have integer n. Test cases have taken care of this position. We have n elements, and b is given for us. B is given, so we'll be taking the elements of b. We have taken the elements of b. Now we are trying to find the vector a. So when we are trying to find that, as I told, we'll be taking one number which will be initially 0, and your, let's take f as the actual b value, what it should have been there. If the numbers in the a very unique, array element a, in the array vector a, if elements were unique, so what would be the actual value? So this is the case. So here what we are going to check, your f whatever you have here, since it is the previous f value, initially element a has no element, so it is 0 element. So when you are finding a1 sorry b1, so in that case you will be adding one extra element. So whatever element you have, that is fine, one more extra element you are going to add, because let's say you have found b2 and you are finding now b3. So whenever you are adding a new element in all the 3f, so since b2 only you have found, which means 2 elements you have found, so your array size will be 2, one more extra you are adding. And now you will have to find if this f is equals to b of I. So in that case you have to increase, since your number is starting from 0, increase the number and push that number in a vector, and yeah, that's it. And if that is not the case, so we'll have to find the difference. And since in the question they have given like b of I is like 10 power 18, so it is long. So wherever you have taken b, try to put long. So I've defined here ll is long, so I'm taking ll, and this f also you take long only, because it is the bi element only. So okay, d, your and difference you can take int as well here. So your difference is going to be, since f is bigger, right, so f minus bi. Now you'll be pushing a of d minus 1, and at the end your f will be b of I, and at the end you will have to display the array elements. So let's try to run it. As you can see here, you have 3 unique elements, right? 1 3 2 and this is 1 2 3. This is going to accept only the uniqueness element whatever you have, that is going to accept. Here you have 2 3 3, so in place of 2 I have taken 1, so it is going to be 1 2 3. So as you can see, this is matching, but the numbers are not same, like frequencies and all are matching. Here you have 3 to 2, here you have 1 to 2. just to in order to confuse you, I mean they've given this is also valid answer, but since I'm following the rules, so I'm starting my number from 1, so that's why this is the case. Here also if you see, it is 4 3 times and then 1, so I'm starting with 1 lesser element, then I'm going ahead, so 3 times 1 and then 2. So in the contest it was accepted here. Now also let me try to submit. What is the problem name? Distinct elements. Yeah, it got accepted. So in this way you could have easily solved the problem. So I think it was an easy only. Basically we had to understand what is this f's, and when you're adding one element, new element, so it will count to the whole answer. But in case your b is lesser, which means you have to repeat those the previous values. So for that, here we have our logic. I think you have understood it. So if you did not, so you just comment it out, so I'll try to help in the comment. So yeah, thank you guys for watching the video.